Today we're going to be learning merge sort. So let's start off with an arbitrary array right here. Let's start off with 1, 0, 5, 7, 3. And we're going to sort this using merge sort. Merge sort is a divide and conquer algorithm, so we're going to take this big array and make it into smaller and smaller pieces and put those pieces back together, back into the bigger array. This is going to use a temporary array to hold in place what we're sorting and plugging it back into the array. So let's start out. So we have the indexes 0, 1, 2, 3, 4. Let's sort of calculate the midpoint. The midpoint is going to be 0 plus 4, so these outer bounds, divided by 2, and we're going to floor that. That's going to be equal to 2. So this is going to be our midpoint. So let's first split. Let's make our first split here. So it's going to be 105, 105, and then we're going to have this split here, 7 and 3. Now we're going to look at this sort of partition we have going on here, and we see that it is 0 plus 2 divided by 2. This is going to equal 1, and this means we are breaking away at 1, so we're going to have a breakaway here, 1 and 0, and we're going to have 5, and then again we're going to break away, and we're going to have 1 and 0. Now this is where the merge happens. We're going to merge these together. So we're going to have this I and j. We're going to have I, and then we're going to have j. Now we're going to have this temporary array right over here. We're only going to need 0 and 1 at the moment. And we're going to ask I this question. We're going to ask I, are you less than j? And we get a no, and then j sort of gets to put their position in. So if j wins this sort of argument, j gets to put their position. J has nothing left to add, so I gets to put in what they want. And now we plug this temporary array back into our array, and this becomes 0, 1. So we've sorted that portion of the array. And so what this looks like in the stack now, we have 0 and 1, 0 and 1. Now we merge 5 together with this array. So we're going to do that again. We're going to get I, so I here, and we're going to get j. Is 0 less than 5? 0 is less than 5. We're going to put the 0 here. I is going to move forward. I is going to move forward. Is 1 less than 5? 1 is less than 5. So 1, and then we're going to need this next index. Let me just draw in all the indexes right now. And we're going to use this next index. And we ran out of places to go, so I is finished, and we're just going to fill in the rest with j, which is 5. This is 5. Now, save on space. I'm going to just write the final result of this. So by the end of this merge, 0, 5, you had 1, it's 0, and then 1, and then 5. Now we have 0, 1, 5. Here, we can start working on this part of the array. Now we're going to do the same thing with the right half. Comes down to 7, 3. 7, 3, it's going to ask the same questions. We're going to get a full merge on 3, 7. 3, 7, so what's going to end up happening is 3, 7 is going to happen here, and our array is going to change to 3, 7. And finally, we're going to have a full merge, down here. And what is that full merge going to look like? Let's draw our I and j. So we're going to have I and j. Now we're going to go through and ask the question again. Is 0 less than 3? 0 is less than 3, so we're going to put 0 here. I is going to move forward. Is 1 less than 3? This is true. We're going to put 1, and then is 5 less than 3? 5 is not less than 3. Finally, j can put in an entry, so we're going to put 3, and then j can move forward. Is I, so is 5 less than 7? It is less than 7, so we get to put in 5. We're out of entries here, so we fill in the rest with j. and that's 7. We copy this finally back into our full array, so our full array gets overwritten with the temporary array again. So we're now writing 0, 1, 3, 5, 7. And that is merge sort. So in our function, we're going to have some driver, and this driver is going to be responsible for setting up the array. So it's usually going to first take the array, and then it's going to give the functions that we need a starting place. So this usually starts off with setting a starting bound, so like a left bound to start with, and a right bound to start with, and passing in some temporary array to work with. This is usually 0 on our start of our array, and this is the length of our array minus 1. Is usually, these are our bounds. And the second thing we have is called the splitter. So this is where we split into multiple portions to be then brought back up again. So this is dividing. It divides the thing into subarrays, the arrays into subarrays. And then we have the merge. We have the merge, which merges all this back together. So it's doing the sorting. This is the I and J questioning. This is the sorting. So this is the questions that we're getting back and forth. Is I less than J? If I is less than J, we sort of take this entry. We take this entry of I. If not, if else, we are going to take the entry for J. And we're going to see this full pseudocode in just a moment. So let's define our driver. The driver function takes in an array. It takes in just a plain array, and it's going to call our split function. It's going to call our split function with these parameters. It's going to first pass in our array. It is then going to give a starting left bound and then a starting right bound. So this could be the length of the array minus 1, and then we're going to pass it the temporary array that we are going to need. This is all we're doing for the driver. This is the setup we need for our split. Let's define the split function. So the split function. Here we're going to take that array the driver gave us. We're going to set the left bound, which was 0, and then the right bound, which was the length of the array minus 1, and then our temporary array that we got to use for our array. The first if statement is going to be if the left is less than the right, we're going to keep splitting. We're going to keep splitting and merging. This is that case where we had one block with one element in it, where at this case the left and the right, like the left and right bounds, are right on top of each other. So no longer is the left greater than the right, so we can no longer split any further. That is going to be our base case. And for our if, we're going to do two other recursive calls, but before we do that, we're going to have to set our midpoint. So that mid we kept calculating. So the mid is going to be equal to the left plus the right divided by 2, and then we're going to floor this. We're going to floor this, and then we're going to perform our recursive splits. So we're going to do splits. We're going to do splits, then we're going to pass it. The array, left, mid, and the temp array. So this is what's going to split us. So we have our midpoint. We have this midpoint. So we're going to get this portion of the array. Then we're going to do splits. And the same thing, the array. And now we're going to actually start from mid plus 1, and the right temp. This is going to give us this other portion, so that we don't accidentally overlap the mid, that we move one space over so we can capture the rest that wasn't taken. That's going to be the split function. And after that, finally, after we keep splitting and splitting and splitting, and we've split it all the way, we're going to finally call our merge function, where we're going to merge all these splits back together. So merge, and we're going to give this the array, we're going to give this the left, the mid plus 1, and the right, and then the temp. This is going to give us both chunks. We're going to have both chunks, so at this point it's going to be mid plus 1. At this point it's going to be mid. This is going to be left, or as we'll see, it's going to be I, and this is going to be the right. J is going to be this midpoint here. J is going to be this midpoint, and this is going to be this ending bound. We're going to call this ending bound sort of RB, so the right bounds, and we're going to call this sort of left bound here the LB, the left bound. So now let's step into what is the merge function. Let's define the merge function. So the actual merge function, that's going to take, again, the array. It's going to take our I, it's going to take the left bound, it's going to take the J, and it's going to have our right bound, the right bound, and the temporary array. Now we're going to have to know where in the original array where to start, to remember this I position, because we're going to change this. So remember where the starting place is and where the finish place is in our array. Let's just sort of save that right now so we don't forget about it later. So we say start is going to be equal to I, semicolon, and then finish is going to be equal to RB, semicolon. Now we're going to have a pointer. We're going to set up a pointer here. Remember in our temporary array, we were looking at each place, asking if I or J were smaller than each other, and we kept moving forward, adding places in. So we're going to have some sort of pointer looking at that for us. So let's set our pointer out, and let's set it equal to I. Now we can start doing the while loop, that question we were asking over and over again. So we can say while, so let me change the colors here. I is less than or equal to LB. Y is less than or equal to LB because we're going all the way across this subarray. So I's subarray and then J's subarray. So we need to know when to stop on that bound, when we have finished or used all of that bound that we have, and J is less than or equal to the right bound. So we need these two bounds to work this magic. Now we're going to have this if statement. We're going to say sort of if, so let me use a different color. We're going to say if it's this question we were asking before, if the array I is less than array J, then in our temporary array pointing at P, so our pointer is going to be equal to array I, and then we're going to do semicolon, then we're going to increment I. So we're going to do I plus plus. This is going to increment I by one. So then else, we have an else, so else we kind of just want to increment. You want to instead on the pointer put the array J. We're going to do J instead, semicolon, and then J plus plus. And at the very end, we're going to increase our pointer, because we either pick one of these, by the end we need to increment our pointer. So let's move down a little bit. So after this while loop, after one of these So one of these is going to run out first, or maybe they don't run out first. So one of these is going to run out first. So this next condition here is going to catch when one of them run out first. This is going to catch if j runs out first. So when I is less than or equal to LB, so we're just going to, if j runs out first, then we just need to fill in the rest with the I. So we have the temporary array, so we're going to have temp, so temp p is going to be equal to the array at I. Then semicolon, then we're just going to do I++, and then we're going to do semicolon p++. Now, that should take care of filling in for I. Now we just need to fill in for j. So while j, so this is the case that sort of I runs out first. So if j right bound, we're going to fill in with the temp again, so temp p is equal to the array j semicolon j plus plus semicolon p plus plus. Then at the end, we're going to do our nice for loop and plug all of these back into our main array. Before, we're going to set m is equal to, remember that start we added at the top? So the starting index is going to be at the start, and we're going to run this for loop all the way to the finish. And this m index, we're going to copy back everything at the m index from the temp. And this should give us the filling in. So that's the merge function. So this is all the code together, and the big O of this is going to be n log n. Now, if you want to evaluate this for yourself, we have a video on recursion where you can learn how to evaluate any recursive function and follow them through. Though the intuition can follow from that we are splitting the problem over and over and over again, and at each step we have to do this linear merging back together. All of these splits incur this log n behavior. We'll make log n splits, but the n comes from the merge, and that is Mergesort. And that is the end of the video. If you enjoyed, don't forget to like and subscribe. If you're looking for more and code implementations, you can go into the description below, and in the description below we have an open source textbook. This is a work in progress, and you're welcome to contribute. You're welcome to open up a pull request or open a GitHub issue if you find any grammar mistakes or think that things should be added. And with that, thank you.